Hello everyone, this is Adnan and welcome to Chemistry with Adnan. On this YouTube channel, I'm covering the entire syllabus of IGCSE Cambridge Chemistry and the course code is 0620. And I also offer like one-on-one tutoring lessons and group lessons on community with the name of High School Chemistry on school.com. You can join it for free. You can attend one lesson per month for free. You can ask questions for free. You can participate in discussions. And, the premium package, just for $20, I offer 4 lessons a month, once per week. These are group lessons where you can interact with me live and you can ask me questions. So the link is given below in the description, so you should check it out. Okay, so now in this lesson today, we will be covering the questions from the past papers based on the topic 7.3, preparation of salts. So this is, one of those topics where students make most mistakes, and they have a lot of trouble answering these questions. So the first question, it says that a list of substances is shown. So answer the following questions about these substances. Each substance may be used once, more than once, or not at all. State which substance. E is a salt that contains a positive ion with a charge of +1. So if you haven't learned or revised the topic 7.3 preparation of salts in a while, so you should go back, watch 7.3, the lesson preparation of salt, which is a video before this one in the playlist. So then you should come back here and then try to attempt these questions with me. So this question is basically related to, the first 2 or 3 chapters where, we learn that group 1 elements, they have a positive 1 charge, and group 7 elements, they have a negative 1 charge, and so on. So so sodium chloride, you can see here that out of all these salts, not all of them are salts, but so here sodium chloride is a salt where the positive ion sodium has a +1 charge. So the answer will be sodium chloride, right? Sodium chloride. Okay, so we move on to the next question. The next question is choose the metal chloride that is insoluble in water. Again, so you have to learn the solubility rules, which are discussed in the previous topic. So silver chloride, right? So silver halides are insoluble in water. So I will, check this box or tick this one. So question number 3C, rust is hydrated iron 3 oxide. Define the term hydrated. Yeah, so a substance chemically combined with water. So I will write here substance chemically combined with water, right? And this water is known as water of crystallization. And and if you heat such a salt, that has water of crystallization, or a hydrated salt, so it will lose water and it will change into anhydrous salt. Yeah, you see, this is again another question from a different paper. So this is the anhydrous copper 2 sulfate because it doesn't contain water. It is not chemically combined with these 5 molecules or 5 moles of water. But on the product side, you can see that this dot between the water formula and the formula of the salt. So this tells us that water is chemically combined here, which is called water of crystallization. And such a salt, when chemically combined with water, that is called hydrated salt. So again, state the meaning of the term hydrated. So the same thing, substance, that is chemically combined with water. Okay, So next question is describe how hydrated copper 2 sulfate is changed to anhydrous copper 2 sulfate. So hydrated copper sulfate means copper sulfate chemically combined with water, and anhydrous copper 2 sulfate means copper sulfate without water being chemically combined to it. So we can say that you just have to heat it, right? So you heat it, so it will be not this reaction, but I'll have to write it like this. So CuSO4 dot 5 H2O. So this is hydrated salt. If I heat it, right, so it will be changed into anhydrous. So instead of writing a dot 5H2, I will write plus 5H2O, showing that now this water has been completely removed from the salt itself, right? So the answer will be we have to heat it. Okay, next question. Zinc chloride is soluble in water. Choose one other compound that is soluble in water. Zinc chloride is soluble in water. Choose one other compound that is soluble in water. Again, you have to learn the solubility rules. So all nitrates are soluble, right? So sodium nitrate will also be soluble. Yeah, lead chloride insoluble, silver chloride insoluble, calcium carbonate insoluble. So how do I know this? This is not some magic, but you have to memorize and learn the solubility rules, which have been discussed in the previous lesson. The link is given below in the description. So you should watch that video, develop your understanding, and then come back, answer these questions. Next question, question number 6. A list of substances is shown. Answer the following questions using only the substances from the list. Each substance may be used once, more than once, or not at all. So give the name of the substance that is a salt which has a negative ion with a charge of -2. Yeah, so this, it means that it must be from group 6. So let's say this is a periodic table. This is group 1, 2, and these are the transition metals, and these are group 3 to group 8. The vertical columns. So 3, 4, 5, 6, 7, and 8. So this group 6, right? Uh, these elements to which oxygen also belongs, and sulfur as well. So they have a charge of 2 negative, right? So uh, sodium chloride, no, it has a chloride has a charge of plus -1. So yeah, negative ion. Okay, it could be a polyatomic ion. So it's the sodium sulfate, because sulfate, is SO4, 2 negative, SO4, 2 negative, right? So, and so in the formula will be Na2, SO4. So how do I know that the formula of sodium sulfate is Na2SO4? Sodium is from group 1, so it will have a positive charge. Sulfate is a polyatomic ion with a 2 negative charge. You should remember this. And now we apply the crisscross method. You should watch lessons from chapter 1, writing the formula of ionic compounds. I've explained it there, right? So this 2 will come here, so it will become Na2, and this 1 goes here, which we don't write, so it will be SO4. So I hope this is clear. So it will be sodium sulfate. Okay, so next question is which of these salts is soluble in water? So barium sulfate, calcium carbonate. Again, the solubility rules, and the answer will be ammonium. So all ammonium containing compounds there soluble in water, right? So this was for both core and extended students. Now, from this point onward, these questions are exclusively for students registered for extended syllabus. So the Haber process is used, question number 8, to manufacture ammonia. Ammonia reacts with an acid to form ammonium sulfate. State the formula of the acid used, right? So state the formula 8C1. Okay, so Sulfuric acid used, yeah, so it is H2SO4. Sulfuric acid is used. It's a memory-based question. State one use of ammonium sulfate. It is used in fertilizer. So we will study this in uh, environmental chemistry, or like the upcoming topics. So calculate the percentage composition by mass of nitrogen in sodium sulfate. So all you need to do is to calculate the molar mass of this compound. So which is, we have two nitrogen atoms. So nitrogen is 14 times 2, plus we have 8 hydrogens. So I will write 8, 4 times 2, 8 hydrogens. So each hydrogen has the atomic mass of 1. We have 1 sulfur, which is with the atomic mass of 32, plus 4 oxygens. So it is going to be 16 times 4. So when you solve this, you should get around 132, right? So now that is the total mass of the molecule. So percent of nitrogen. So what is the mass of nitrogen here, which is 28? So 28, which is the total mass of nitrogen present in the formula, in the form of 2 nitrogen atoms with the total mass of 28, 14 plus 14. So 28 divided by 132 times 100 should give you the answer, which is around 21.2%, right? So I hope this is clear. So copper is element 29 in the periodic table. Hydrated copper 2 sulfate is a colored compound. It exists as hydrated crystals which contain water molecules. So state the term given to the water molecules present in hydrated crystals, water of crystallization, right? So you shouldn't write here that hydrated salt, right? Or something else. So it is water of crystallization. State the color of hydrated copper 2 sulfate crystals. Memory-based question, it is blue. You have to memorize this. Write the formula of hydrated copper 2 sulfate. So same, memory-based question. CuSO4.5 H2O. These salts are included in your syllabus. One of them is, copper, and the other salt is related to cobalt, I believe. Yeah. So propanoic acid results with the aqueous sodium carbonate to form a salt. Okay, so suggest the name of the salt formed. All right. Okay, so I have answered this question in my previous lectures as well. So propanoic acid is a carboxylic acid with 3 carbon atoms. So the formula is CH3, CH2, COOH, and sodium carbonate is Na2CO3, because the polyatomic ion CO3 also has a 2 negative charge. So how do you write the product, right? So, this propanoic acid, when it dissociates, it changes into, propanoate ion, right? So it will be CH3, CH2, COO negative. That is a propanoate ion. And it will combine with this sodium, right? So it will become sodium propanoate. So it will be CH3, CH2, COONA, right, plus water, H2O. So and a carbon dioxide will also be released, since a carbon dioxide is a carbonate is being used. But anyways, here the name will be sodium propanoate. So sodium propanoate. Okay, so if they change the name of the salt from propanoic acid to ethanoic acid, and the name of this other compound, they change it from sodium carbonate to lithium carbonate, for example, so Li2CO3. So then what will be the name of the salt? It will be lithium ethanoate, right? So ethanoic acid will become ethanoate, propanoic acid will become propanoate, butanoic acid will become butanoate, and whatever the other reactant is, so the name of the metal from the other reactant will be written first. So it's sodium carbonate, so the name of the salt will start from sodium, and then whatever the carboxylic acid is, it will end in ATE, right? So propano, so you remove IC and acid and you just write ATE, right? Yeah. So I hope this is very clear. Now we move on to the next question. It is suggest the formula of the anion in this salt. Yeah. So you see, this is, you should know that propanoate. This is the formula CH3, CH2, CH2, and COO negative. Suggest the formula of the salt of the anion in this salt. Yeah, I hope this is clear. Now we move on to the next question. So give the letter A to J for the equation that represents a precipitation reaction. So how will you figure this out, that which one of these is the precipitation reaction? So again, you should know the solubility rules, and solubility rules tell us that iron hydroxide, so hydroxides, they are mostly insoluble, and iron hydroxide is insoluble. So these ions, iron 3 and hydroxide, they combine together to make this thing, and this is solid, right? This is iron 3 hydroxide. So you give the letter, so the letter will be A. So I hope this is clear. Now, what is a precipitation reaction? A precipitation reaction is the one where you mix two substances, and as you mix them together, something will suddenly become insoluble, which was soluble before mixing, but when you mix them together, a reaction will take place, and it will change its state from being soluble to insoluble, and it settles down. That is called a precipitation reaction, right? So yeah, so I hope this is clear. Now, question number 12, magnesium, calcium, and strontium are group 2 elements. Aqueous silver nitrate is added to aqueous magnesium chloride. A white precipitate forms. Write an ionic equation for this reaction. Include state symbols. Magnesium, calcium, and strontium are group 2 elements. Aqueous silver nitrate is added. So silver nitrate is AgNO3, which is soluble in water, is added to aqueous magnesium chloride, MgCl2. So they both are soluble compounds. And okay, what else? It says that at white precipitate forms. Very simple, right? So AgNO3, when it reacts with aqueous, when it reacts with magnesium, chloride, aqueous, so a double displacement reaction will take place, and the salt that will be produced will be silver chloride, AgCl, plus and magnesium nitrate, right? So, and magnesium nitrate will be NO3 and twice. Yep. Okay. So now this is aqueous, because all nitrate containing ionic compounds are soluble in water. But the solubility rules, they tell us that, when halide is connected with silver or lead or mercury, it will be insoluble in water. So I hope this is clear. Oh, why did I write AQ? This is solid. Okay, so now write an ionic equation for this reaction. So the ionic equation will consist only of the part where a solid is created and the ions that are involved to make that solid. So you'll start with Ag plus, right? Aqueous plus Cl minus aqueous, and we get AgCl, solid, right? So on the left hand side, while writing the ionic equation, most of the times we will have, positive and negative ions, and on the right hand side as a product we will have, an insoluble salt. So I hope this is clear. Now we move on to question number 13. So this question, uh, it says that sulfuric acid has many uses. Dilute sulfuric acid is used to make salts known as sulfates, blah, blah, blah. Suggest two observations which show that the reaction is complete in step one. Okay, I have to read this. A method, dilute sulfuric acid is used to make salts known as sulfates, yes. A method consisting of 3 steps is used um, to make zinc sulfate from zinc carbonate, okay. So add excess of zinc carbonate to 20 centimeters cubed of, okay, we have a sulfuric acid in a beaker with the volume of 220 centimeters cubed, and its concentration is 0.4 mole per dm cube, right? Okay, and okay, add excess, and we are adding, excess zinc carbonate, right? Zinc carbonate. So yeah, and okay, suggest two observation. Okay, filter the mixture. Yeah, so and heat the filtrate until a saturated solution forms. Then allow it to crystallize. Suggest two observations which show that the reaction is complete in step one. Okay, so that and during this reaction, since it's a carbonate, so uh, you know uh, there will be fizzing, like when it is reacting with acid, carbon dioxide will be released, so the fizzing will stop. So you can say that no more fizzing, right? Once all of the acid in the beaker is consumed, so there will be no more fizzing. So we can write here that no more fizzing, or you can also say that the bubbling will stop, or there will be no more bubbling. And the second one will be that, when once all the acid is consumed, so if you add more zinc carbonate in the beaker, so it will stop dissolving, right? It will stop disappearing. So we say that, a white solid remains, or we can say that zinc carbonate stops dissolving. So a zinc carbonate, or you can write the name, no need to write the formula. So zinc carbonate stops dissolving. Yeah, so I hope this is clear. So we move on to the next question. Okay, let me write down the whole equation as well, right? So just for extra information so that you can understand it even better. So it is zinc carbonate reacting with sulfuric acid, H2SO4. So they are going to produce zinc sulfate, uh, and yeah, plus carbon dioxide plus water, right? So this is the reaction that takes place, right? So okay, I should I balance this equation? I think that is unnecessary. Yeah, I think it is already balanced. 4, 5, 6, 7, 4, 5, 6, 7. Okay, yeah. So state why it is important to add an excess zinc carbonate. This is the question which most of the students, they don't get. So I have explained it in a lot of detail in my previous lesson for 7.3, preparation of salt. So go watch it, develop your understanding so that you can understand this question. So state why it is important to add an excess of zinc carbonate, because you know once the reaction stops, so there will be some excess zinc carbonate that will be insoluble and present in the mixture. So we need to, this is aqueous, zinc sulfate is also soluble, so we remove this by filtration. So we filter this mixture, right? And we pour the contents of this beaker over a funnel and we filter it. So the salt, it will be trapped here, and the liquid part will come here. Right now, you have to heat this beaker in the second step, right? So if there is acid present in this solution, and so it will, by heating it, it will lose water, and it will become more and more and more concentrated, which can become very dangerous, and it can cause serious burns, right? So that is why we make sure by adding excess zinc carbonate, so that all of the acid in the beaker has reacted, right? So the answer will be to use up all the acid, to use up to use up all the acid. Okay, so the next question is define the term saturated solution, a solution that can hold no more solute, right? A solution at a specified or a specific temperature, a solution that can hold no more solute, right? And yeah, at the specified temperature, because solubility is always related to temperature. It is if you increase solubility, solubility increases. If you increase temperature, solubility increases. So whenever we measure solubility, so we write the temperature we are measuring solubility at, right? So I hope this is clear. So the next question is, name another zinc compound which can be used to zinc sulfate from dilute sulfuric acid using this method. So you can use zinc oxide, or like you can also write zinc hydroxide, right? So these are the compounds that can be used, right? So they must be insoluble. So any zinc containing molecule can be used that is insoluble and that reacts with sulfuric acid, right? Suggest why this method would not work to make barium sulfate from barium. A very tricky question, a difficult question, in fact. Suggest why this method would not work to make barium sulfate from barium carbonate and dilute sulfuric acid. Because barium sulfate, if you look at the solubility rules, it is insoluble, right? So it will be very difficult to remove, to filter two different salts. So I hope this is clear now. The next question is question number 14. And how many questions have I selected? Okay, okay, we are about to complete this. So potassium is a group 1 element. Name aqueous potassium hydroxide reacts with a dilute acid to produce aqueous potassium chloride. Okay, so a chloride salt we are getting, so the acid will be, hydrochloric acid, right? HCl. Because we have learned in our previous lesson that HCl produces a chloride salt. So I hope this is clear. It will be hydrochloric acid. State the type of reaction taking place. Yeah, so whenever acid and base, potassium hydroxide, it is a metal hydroxide, and acid is an acid. So whenever acid and base react, the reaction is known as neutralization reaction. So it's neutralization. Name the experimental technique used when salts are made by reacting a dilute acid with an aqueous alkali. Titration, right? Yeah, so we put acid in a burette, and in a conical flask, we take a base, right? And uh, yeah, we put some indicator here, which will tell us the end point. and how we're going to stop adding more acid, and it will be the neutralization reaction. And the hydrogen ions will be the same as the OH negative ions. Their quantity will be the same, and yeah, so all of the acid or all of the base will have been neutralized by the acid. So state the color of the precipitate formed. Again, a memory based question, right? So uh, yeah, silver chloride, uh, potassium chloride, chloride ions, they give you a white precipitate. So how to detect halides? So chloride will have a white precipitate. Bromide will have a cream precipitate, and iodide will have a yellow precipitate. Remember that. Okay, so write the name of the precipitate formed. It will be silver chloride, right? Silver nitrate reacting with potassium chloride. Name of the salt will be silver chloride. So it will be silver chloride. Okay, write the ionic equation for the reaction. So again, silver chloride is the product. So we have to write the ions that are involved in the production of this thing. So He plus and Cl negative, that is the answer. Okay, silver, state symbols, so aqueous, and this will be solid. Okay, question number 15. A student, let me write the equation of this as well. So AgNO3 plus potassium chloride, KCl, right? So how will you write the product? So the metal from salt, it's a double displacement reaction. So that's a metal, silver. It will combine with the non-metal of the other reactant, which is chlorine, and they will make silver chloride, solid. And the metal part from the other salt will combine with the non-metal part of the other reactant. So it will be potassium nitrate, right? And it is soluble. All nitrate molecules are soluble. So yeah, and now I think you will have a better understanding of this. So we have another question similar to this one. A student prepares a calcium nitrate. Okay, a student prepares calcium nitrate, so that's a product. So I'm going to write it here. So by adding calcium carbonate, so okay, so very simple question. They have given us the names of the reactants, so the chemical equation will be, since it is nitrate, so it will be aqueous, right? It will be soluble in water. So calcium carbonate is CaCO3 plus dilute nitric acid, so HNO3, right? So this will be plus CO2 plus H2O. Since a carbonate containing compound is involved, so we learned in our previous lesson that you know whenever a metal carbonate reacts with acid, carbon dioxide and water are produced along with the salt, right? So describe two observations during this reaction. Since carbon dioxide is produced, it's a gas. So this is liquid, this is gas. So there will be bubbling or effervescence, you can write, and or fizzing. And then, this calcium carbonate, it will disappear because it will completely react with nitric acid, right? So you can say that the solid disappears or the solid dissolves. So solid disappears. Okay, so okay. Next question is, the student continues to add calcium carbonate until it is in excess. Okay, so we have this beaker and we are adding uh, more and more calcium carbonate, uh, you know, so until we start seeing, precipitate of calcium carbonate, no, it cannot dissolve anymore. So it will start settling down at the bottom. So the student then removes the excess calcium carbonate by filtration and collects the aqueous calcium nitrate. Okay, yeah. So state the general term given to the solution collected from filtration. Oh, that is a filtrate, right? So when you filter this thing in a filtration funnel, so whatever is left behind on the filter paper, that is called a residue, and whatever is collected in the beaker, that is called a filtrate. Whatever can pass through the filter paper, that is called a filtrate, right? So filtrate. Okay, so the student gently heats the aqueous calcium nitrate. Yeah, so we have calcium nitrate here until the solution is saturated. What is meant by the term saturated solution? Saturated solution, again, I think we discussed it. So a solution that can contain no more solute at a given temperature. I'm not writing it again. Describe how crystals are produced from a hot saturated solution. It is allowed to cool down, gradually cool down. So most of the solution is evaporated in an evaporating dish. So, when most of the water evaporates, the salt that was once soluble in this dish, now it will not be able to remain soluble, and it will start to precipitate out, right? So the answer will be, we can say that cool the solution, right? So cool, hot saturated solution. So when we allow it to cool down, cool the solution. So then the crystal will appear, and then we can wash them, and we can leave them to dry, right? So we will get pure crystals. So now I think the questions are being repeated. State the term used to describe the calcium nitrate after the molecules of water have been removed. Anhydrous. Salt without water of crystallization. That is called anhydrous salt, right? So the next question is not included to the preparation of salts. I have, in my previous past paper questions, I have answered this many times, but this question is specifically related to the topic of stoichiometry. So you should go watch those lectures from the past paper series. There is a separate playlist. So we will see. Okay. So, all right, then I think we can stop here. Write the chemical equation for the reaction when solid sodium nitrate is heated. That is a decomposition reaction. It's a last question. So let me just write the components. So 2NaNO3, that is the formula of sodium nitrate. It will change into NaNO2 plus O2, right? So that is the equation. All right, then. So this was all about past paper questions based on 7.3, preparation of salts, a fairly difficult topic. But yeah, like you need to have the knowledge, have the foundation to understand these concepts. What concepts are involved? You should be able to know the solubility rules. You should be able to understand the writing the ionic formulas. You should know how to write the ionic equations. You should be able to translate the name of the salt back into its actual formula, right? So these are some of the topics or some of the skills that you must have in order to correctly answering these questions. I'll see you in the next one. Take care. Goodbye.